So, I suppose you're wondering why I called you all here today. I've always wanted to say that. They always say you should get into an elevator last, turn around with your back to the door, and then say that to everybody else in the elevator. It's going to be a tough crowd. Okay. Anyway, well, welcome to this afternoon session on full stack reactive Kotlin. I proposed this with Java. I have been working with Kotlin for a long time, so I thought, why not just mix it in too? Why not just throw that in? No extra charge. We're going to do a lot of Kotlin, a little bit of Java. We're going to just have a great time. This is going to be a create your own adventure today, so I hope you're all buckled up and ready to go. So anyway, we're going to be using Spring Framework 5, Spring Boot 2, and Project Reactor. For those of you who don't know me, my name is Mark Heckler. I'm a principal technologist and Spring developer advocate with Pivotal. Pivotal are the makers of such fine software components as Spring Framework, Spring Boot, RabbitMQ, Greenplum, Gemfire, huge contributor to Apache Tomcat, huge contributor to the Apache the Cloud Foundry Common Code Line. You may have heard of us. We're a tiny little startup out of Silicon Valley. Not quite so tiny anymore, but still very nimble, right? I blog semi-regularly, not as often as I would like, admittedly, but I blog from time to time at thehecklers.com, my personal domain, as well as occasionally on the pivotal.io and spring.io pages, sites. But I tweet very regularly at mkheck. Is anyone here on Twitter? Anyone? Okay, a couple people. That's pretty good. I live on Twitter. I actually, it's not really much of an exaggeration. I'm on Twitter from the time I get up to the time I go to bed. There are times I wake up in the middle of the night and even grab my phone from the hotel nightstand and tweet even then. Probably a sad indication of my life, but there you have it. I actually made the comment a couple of months ago that I lived on Twitter more than I lived in my home. And then I got to thinking about it. Oh my gosh, what if that's true? So I figured it up, and yes, there are some months, many months out of the year that I spend more time on Twitter than I do at my house. So thank you for letting me spend part of that time here with you. I say all that to say this. If you have any questions or comments or feedback, they tell me we only have 3 hours here today, right? 2 hours today. Well, according to the sign, only 48 minutes left. So that's not really enough time for me to cover everything that I want to cover. It's enough time, though, to start the conversation, right? So I will be hitting a lot of stuff kind of quickly, hopefully not too quickly. I don't like to just blast past stuff, but I will be trying to cover a lot of ground, right? If you have any questions or comments or feedback, please do reach out. I love to talk. I love to code. This kind of lets me combine both, right? So reach out to me. The best way to reach me is on Twitter. As the best way to reach many of your favorite open source committers, right? So please do reach out to me on Twitter. However, if you have questions, comments, or feedback that don't fit neatly in 280 characters, or you hate Twitter or what have you, that's fine. I'm also a member of the slightly older and more established social network called email. Is anyone on email? Okay, a couple more hands. That's pretty good. This is really a forward-leaning crowd, I can tell. So like you, I have about a half a dozen of different email addresses. These are my two favorites, Mark at thehecklers.com and mheckler at pivotal.io. These are the two that I check the least infrequently. Wait for it. Okay. I don't live on email like I do on Twitter, but I do check it from time to time. So if you have any feedback for me, please do reach out. One way or the other, I will respond. It just may take me a little longer if it's not on Twitter. So with that, who am I? Well, I've co-authored a couple of books. I have contributed content and code to several other books, some of which even recognize my contributions. That's always nice, right? But it's open source. It's all good. I am a frequent event speaker. It was really nice to be invited back to Devoxx and to be able to make it. So thanks for inviting me back. Any first-timers here? Wow, that's really good. Hopefully they'll let you come back too, right? Hopefully they'll let us all come back. Devoxx is an awesome conference. I probably don't have to tell you that, but I do just like to remind you what an absolute gem this is and what a privilege it is to be able to come here. So hey, welcome, first-timers and all of us, right? So I am an architect and developer, and as most of you might surmise from the next bullet point where most of my expertise has been won, it's in the realm of Java. I was inducted into the Java Champions for ongoing contributions to the greater Java community about 3.5 years ago. If you had anything to do with that, thank you very much. Appreciate the vote of confidence. I do take that very seriously, and I love the community, right? And I am a seeker of a better way, as are you, or you wouldn't be here today, right? Our industry suffers sometimes from shiny object syndrome. Not a good thing, right? Chasing the latest fad, the latest JavaScript framework of the moment. I used to say of the day, but I mean, they're coming out far more frequently than that. But I do think it's important to search out new tools and new solutions, because new solutions, new options, new tools allow us to solve problems that may have been previously intractable, or that may not have had a particularly elegant solution. So it's very important to constantly be exposing ourselves to new ideas, new processes, new tools, new tool sets. So, you know, this is part of it, right? So I did kind of blithely skip over something that's very, very important, and I immediately regret that. I do need to take a speaker selfie with you so I can prove to my boss that I actually was here doing something other than just sampling the craft coffee and craft beer scenes here in Antwerp. So if you could help me out and validate my presence here, that I'm working. So everybody say spring. I have such great photography skills. Hopefully one of these will turn out. Okay, middle section, say spring. Wow, you're just bowling me over with your enthusiasm. Oh my gosh. Am I in the right room? I guess I should start with that. They did let me plug in, so I guess it is. Okay, so this side, you gotta help me out, because the middle is rather the mushy middle, right? Okay, so spring. Oh, that is so much better. Middle, you want to try it again? Try to redeem yourselves? Ready? Okay, spring. Wow. Okay. Sounds like somebody else needs coffee. I have only had like 6 espressos today, so I am really running low. So this is going to be a slow-paced presentation. So with that, what is this reactive stuff? A lot of times we kind of start off the conversation with what is reactive programming? What can it do for me? I like to start with this quote by Rossen Stoyanchev, one of our Project Reactor team members, in which he said, in a nutshell, reactive programming is about non-blocking event-driven applications that scale with a small number of threads, with back pressure as a key ingredient that aims to ensure producers do not overwhelm consumers. Now, there's a lot of context packed into that one statement, which is why I love it. But let's unpack it a bit, shall we? For starters, the concurrency model, the scalability of Java has largely been very easy to understand over the years. It's been a matter of, with additional requests, with additional connections, you have additional threads, right? For each new connection, you have a new thread, which leads to a large number of threads at any given point in time, potentially, that are doing what? Nothing, right? They're blocking. They're waiting for a response from another service, from a database call, from a file system call. So what you find is that it's very easy to understand, but it's not terribly efficient. So we find by inserting an event loop into things, we can actually do more with less. We can service more requests with a smaller number of resources, a small number of threads, if you will. What optimally should happen is you should have these threads that are kind of self-managed. I shouldn't say self-managed, but certainly you don't have to fine-tune and manually tweak how you want these to handle your various different requests in the event loop that is servicing them. We don't want one thread. One thread is easily hijacked and crushed when there's a bad actor in the mix. So that's not necessarily ideal, but a small number of threads seems to make a lot of sense. You should also, I guess, conversely to what I just said, you should be able to tweak that. You should be able to do some specifications and to determine how those threads handle the request coming in, should you want to. It's just that you shouldn't necessarily have to, right? Back pressure is a key ingredient. I like to point out, has anybody here done any asynchronous programming? Because asynchronous programming kind of addresses some of this, right? But asynchronous programming suffers from a couple of different things. Probably none of you have ever heard the expression callback hell, right? It's entirely new to all of us. What you find with asynchronous programming is that you typically will have some form of a when you get done, do this, right? A callback. And over time, of course, or over, I shouldn't say over time, but over a significantly complex set of processes and processing, what you wind up is a callback that calls a callback that calls a callback, and eventually you have what is termed callback hell. It's not overly clear, let's say, as a nice way of putting that in your code. What we want is a mechanism that allows us to more clearly define what should happen in a reactive or an asynchronously processed set of actions, right? Backpressure is another thing. Asynchronous programming by itself, in and of itself, doesn't define any way for a consumer, a slower-moving consumer, to push back, to say, I can't handle that many data values, right? It doesn't change the fact that you may have a producer that's producing 1,000 values per second, and you have a consumer that can maybe only handle 5 or 10. But with backpressure in reactive programming, you have backpressure that allows a slower consumer to say, look, I can only handle 10 values at a time. Just give me 10 values at a time. And when I'm ready for more, I'll request more. Again, doesn't change the fact that you're producing a lot more perhaps than can be consumed by that particular endpoint. But what it does do is shift the ability to address what happens to those other 990 values back to the service, back where we typically have more control, right? So that's a very, very quick and high-level broad brush overview, but I think it will serve us to get started with this. So all this is based on the Reactive Streams initiative. Some very intelligent people a few years ago now came together and said, look, where most of the issues with scalability come in are in the interactions, the streams, if you will. When services are talking to services, when they're, again, talking to making a database request or hitting the file system. So it makes sense to concentrate on the streams, on the interactions, and see if we can maybe make that a bit more or much more efficient. So they came together, and again, in our industry, we've never, ever, ever seen before one company or one organization solve a problem that's completely incompatible with everyone else, right? That never happens. Fortunately, we're seeing less and less of that, right? So this is a great example of that. We had several companies who came together and said, look, we can all solve this in incompatible ways, but when we do that, who gets caught in the crossfire? Us, right? The developers. We're the ones who have to try to plug this weird plug into this weird outlet and make it all work. Thank goodness for power adapters, right? But, that gets to be really cumbersome and not terribly efficient. So they came together and said, look, and I'm pacing and I'm probably giving the video guys fits, so sorry about that. I like to move, and when I code, I can't move. So they came together and defined the Reactive Streams specification. The Reactive Streams initiative includes 4 things. One is the textual spec, kind of explains what we're trying to do here. One is the API itself. One is examples to show how to actually to implement that API. And the final thing is arguably the most important, which is the TCK, the Technology Compatibility Kit. This allows anybody who's created an implementation of the Reactive Streams API to verify the level of compliance, so that they know what to fix or where they are falling off the trail, so to speak. And it's a very simple API. There are 4 interfaces defined in the Reactive Streams API. The publisher, which is the thing that creates values, right? The subscriber, which is the thing that consumes those values. A subscription, which is the contract that in between a subscriber and a publisher. And then a processor, which actually incorporates both the subscriber and the publisher interface so that presumably it can grab a value, manipulate it in some way, and then pass it on. So there are many implementations, as I mentioned, that should all be very, very interoperable, demonstrably interoperable. Project Reactor is the one that Pivotal shepherds. And I want to be very clear. There's a lot of cooperation. Anyone remember Novell? I'm an old guy, so Novell is, plus I love computer history, so it's kind of a twofer. The guy who headed up Novell years and years ago, Ray Norda, coined this term called coopetition, which I dearly love. It kind of wraps up in that one word 2 concepts. You should be able to compete in your industry while still cooperating with the other competitors, right? So again, your customers, your developers don't get caught in the crosshairs. So here is is our particular implementation, but we get along well. You know, we work with the Akka Streams folks, the Vertex folks, the RX Java folks. I'm very fond of pointing out, because I'm very proud of it, that David Karnock, who heads up the RX Java 2 effort, is a huge contributor to Project Reactor, and Stefan Maldini, who heads up our effort, contributes as well, vice versa. So I think that's something to be very proud of. There's a lot of cross-pollination, but everybody has a little different take on what an implementation of Reactive Streams should be. Project Reactor builds on your existing knowledge base, and that is something also I'm very proud of, because I think we're doing it right. There are other implementations that say, you know, you've got, I guess I should ask, who here is a Spring MVC developer? Who here has developed some in Spring, right? So you've got some hard-won knowledge that you've built up over 5, 10, 15 years, right? I mean, this is stuff that you apply daily to make your organization a lot of money or to service your organization's customers. These are mission-critical systems, and you've gained a lot of expertise in building those. It makes no sense to look at a reactive tool chain that tells you to forget all that hard-won knowledge. Throw it away. It's useless. It does you no good. At least it doesn't make sense to me, right? Especially when there's a way that you can build on that knowledge and still give you the full power of a reactive stack, which is where Project Reactor comes in. It builds on a couple things you're probably very familiar with, right? Java 8. So Java 8, completable futures, streams, lambdas, duration, things like that. Stuff you use probably every day. And Spring MVC concepts. We're not getting rid of Spring MVC. What we did is create a set of parallel capabilities and parallel packaging. So you have Spring Web MVC, one package, Spring Web Flux. I'll come back to that name shortly, okay? But it's twice the work for us, but it makes it very simple for you. There's very low friction in context switching. I mean, most of us are going to be working on Spring MVC apps for a long, long time, and that's good. Again, it keeps organizations afloat. But that also means that when you start incorporating reactive applications into your portfolio, there's going to be this mix for a while, for the foreseeable future. To have massive context switching when you switch between applications you're maintaining or building, writing, that's tough. And that shouldn't have to happen, and it doesn't, right? So as you're well familiar in the imperative world in Java, when you return, for instance, a return value from a method, you return an object of type T, for instance. Or you may return an iterable of type T's, right? A collection of some form. So in the Reactive Streams world, you have this one thing, which is a publisher, which can return 0 to an infinite number of values. We felt it made sense to kind of specialize that interface a bit. So we have a mono, which will return 0 or 1 values, sort of like the object of type T. Or we have a flux, which can return a small collection, a reactive list, if you will, so to speak, of values. Or maybe even an infinite number of values over an indeterminate amount of time. That's the flux. Now, you'll have some operations which apply to both, monos and fluxes, quite well. You'll have others that only apply to one or the other. So again, it makes sense to specialize. Non-blocking interprocess communication, I kind of have briefly touched on that. But you have back pressure ready network engines for HTTP. So you've got TCP, UDP support, WebSocket, server sent events. And there's some actually really cool stuff that was announced at Spring One Platform, our conference a month and a half ago now, I think. We're working with Facebook and other companies to create RSocket, right? And Facebook's already implementing this. So it's all already live in some places, right? You're probably already using it. So that's a pretty exciting time to be alive. So with that, let's code. Does anyone recognize this guy? Thank goodness, you are my people. Okay, so occasionally I'll ask that and I get nothing but blank stares, which always makes me a little bit sad. Those of you who don't know who this is, to quote another one of my favorite TV shows, I'm sorry. I'm so sorry. I'm a big Whovian, too, by the way. So this is from the IT crowd. It's a Britcom from a few years ago. It actually holds up remarkably well, for the most part. It may or may not be on Netflix here. I'm just not 100% sure. But it is? Okay, good, because we're coming up on a weekend here. Those of you who haven't seen it, I'm going to give you an assignment. This is far more important than anything else I will say here today. You need to go and watch the IT crowd, right? This will make you laugh. It will make you cry. It's just that good, right? So it was only like 4 seasons of it, 4 series of like 4 to 6 episodes, I think, each. It wrapped up rather abruptly, and it didn't get a clean finish. So when the showrunner was asked a couple years later if he wanted to kind of come back and do a 2-hour special and put a nice bow on it, he said, sure, but I'm not sure how many of the actors will want to come back. Everyone signed up, which ought to tell you something. It was really a beloved show and just awesome. This is Maurice Moss. He's one of the protagonists in the IT department. Hopefully this will not go like this, but you know, live coding, you just never know. So we'll see. All right. So we'll start off here. Does anyone recognize this? Yes, this is the Spring Initializer. This is your starting point for Spring Boot-based microservices on the web. So whether they're imperative or reactive, doesn't matter. You can start here. You don't have to start here. You can actually go to the website, you can curl it, you can go through your IDE, you can write it all by hand if you want to. It's not the most productive thing, probably, but you can do it. So what I would suggest is you come here like I do because it's so pretty. I'm not a designer though, what do I know? So with Spring, all things Spring, you have an opinionated approach, so you can get up and running very fast. If you want to customize this to your heart's content, you can go down here, you can choose your packaging, your Java version, all the way up through 11 currently, of course. You can go through and choose off the menu the things that are version synchronized with the current version of boot you select. Of course, you can bring your own dependencies. Of course, you can override versions should you want to. But these are the versions that have been synchronized with the current version or this version of boot or that version of boot or whatever. And it saves you a lot of time. Has anybody ever played the game of dependency whack-a-mole? Yeah, those of you who are laughing know it. Those of you who haven't yet, you will. It's just bound to happen, unless you're using boot. But if you have multiple libraries that you're using for your application, and you update a few of them, or all of them, and things stop working, and you get no valid information as to why, and you do all the right things, right? You troubleshoot it. You go to Stack Overflow, you go to Google, and you try, you consult the Googs, and nothing. And finally, you just try rolling back a version of a library, and everything works. Congratulations, you found a new conflict, right? So you don't have those dependency whack-a-mole games if you're using the list that's right here. Now, of course, again, you can specify, you can bring in your own, that's fine, but for the most part, this takes a lot of that mess off your plate, which is pretty sweet. So I'm going to go back to the simple version because I'm a simple guy, so let's just start here. With the Spring Initializer, it allows you to specify your dependencies and get up and running fast. Download your project, it zips it up, you download it. It doesn't actually generate any code other than your main application class and main method, but it actually generates your project. So you have options even then. If you are a Maven developer, you can generate a Maven project. If you're a hipster, you can generate a Gradle project. As you may have noticed, I'm wearing my hoodie today, so I'm going to go with Gradle because I'm feeling pretty hipsterish. Oops, I just misclicked. That's embarrassing. We do support Java, Kotlin, and Groovy. And this is one thing that I sometimes get from people is like, why should I bother with Kotlin? Java is now on a 6-month release cadence. There's more newer stuff that's coming in faster. Why should I mess with expanding into another language? I think there are several answers to that, right? One, I don't think you have to. I mean, if you're happy with Java and it's doing everything you need, that's great. Java has done a great job of maintaining backward compatibility for the last 20 plus years, with the unfortunate exception of Java 9, of course. But let bygones be bygones. But it does maintain that backwards compatibility, so there's a much greater burden on their shoulders many times when they have to or need to provide a new implementation of some capability within the language. Kotlin is much less constrained. So they're a little more nimble. And I think many times that the two teams kind of eye each other and complement each other quite nicely. Because the Kotlin folks are certainly not reckless at all, but they are not quite as constrained, right? Due to 23, 24 years of Java, I think. So they're a little more free to innovate, if you will. And I think, I know that the Java teams actually watch that and see what is taken and picked up and gets mass adoption, right? So, last fall of 2017, Spring Framework 5 went GA. Spring Framework 5 had 3 major stories. One, it rebaselined at Java 8 instead of Java 6. I like to say that we supported Java 6 longer than Oracle did, which is true. But it also allowed us to replatform and get kind of that new baseline, so we get the, again, completable features, lambdas, streams, things like that. It also incorporated Project Reactor, so you got Spring WebFlux, or the Reactive Spring capabilities, which was very nice. And the third was full first-class support for Kotlin, which is very, very important. This was not a decision that was made lightly, but Kotlin is a very solid language with a lot of support, and it gives you, oh dear, and it gives you a lot of capabilities that you will see in Java eventually, but aren't quite there yet, right? Kotlin, with that, became supported by the framework that is responsible for more and supports more than 50% of all enterprise Java applications. It also, a couple of years ago, was endorsed by Google as an option to developing Android apps. This past year, they actually said it was the preferred way, the recommended way to develop Android apps, not Java, Kotlin, right? So I think that tells you that it's a very important player. It's not a bad language to learn. It's very easy to learn for a Java developer, and it's super nice. So you'll see quite a bit of that today, hopefully. But we do support Java, Kotlin, and Groovy. I'm going to be going with Kotlin for the most part today. Hopefully I'll have time to do the, if nothing else, the client, and I'll do that all in Java. Everything works. I mean, you can always also mix and match within an application, which makes it almost trivial to migrate over time to Kotlin as well. So I'm going to choose Spring Boot 2.1.0. I'm going to change this to the Heckler as my group, because it won't work otherwise. Kidding, it'll work. I just like it better. So I'm going to do what I love. They always tell you to do what you love in life. So I'm going to do what I love. I'm going to create a coffee service. I love coffee. Does anybody love coffee? A lot of coffee haters out there. I'm just kidding. So coffee is good. It's been at least an hour since I've had any, so I'm in withdrawal. So I'm going to bring in the dependencies that I need. Reactive Web dependency gets me my Netty and Spring WebFlux. In Spring MVC world, Tomcat is the default servlet engine, but you can swap that out. Similar in the reactive world, Netty is the default runtime engine. But you can swap that out as well with any Servlet 3.1 compatible engine, so things like Tomcat 8, let's see, what is Jetty, Undertow, all fine options, but I'm going to stay with Netty for the time being. Let's see, I'm going to also bring in Reactive Mongo for my data store. There are 4 databases that support fully reactive interactions through Spring Data: MongoDB, Couchbase, Cassandra, and Redis. And we also have another initiative that we're kind of leading the charge on, again, with some folks, good folks from MariaDB and Postgres and others, to do a reactive relational database connectivity. So JDBC is not reactive, it's blocking at its very core. So we're trying to create a parallel, and work is being done on that very early stages, but it's very exciting stuff as well. So I'm going to bring in Mongo. I'm also going to bring in embedded Mongo. For a couple of reasons. One, it makes it easier to demo, and 2, I love the name. So we'll get back to that here in a moment. So I'm going to generate the project. I'm going to just drop that here on my desktop, save, and then I'm going to, once that finishes downloading, wow, Wi-Fi is super fast. All right, so let's open that up in our favorite IDE, NetBeans. Ha, just kidding. So who here likes NetBeans, uses NetBeans? It's a good IDE, right? I mean, it has great support for Spring. Any Eclipse users here? Really? Okay, anyway, choices, that's fine. No, we have actually a build of Eclipse called Spring Tool Suite, which actually has some really cool cloud deployment capabilities. Every time I see them, and they get better and better every time I look again. It makes me a little wistful, but I love IntelliJ. It just fits my workflow really well and supports what I need to do. So that's what I stay with. Right? So let's see. The first thing I need to do is go to my build.gradle file. I do need to make a small change because, and this also lets me kind of show this. So embedded Mongo was created by a German fellow who, of course, named it something very serious, very German. He named it flapdoodle. I can't even say that without laughing. Flapdoodle, right? It's just so good, because we know Germans are known for their sense of humor. So actually, I know you'll probably be thinking, Heckler. Yeah, it's true. Most of my heritage is German. My wife told me years ago, and still reminds me, that I'm unintentionally funny. And I think I finally figured out what that means. So anyway, but flapdoodle, I mean, who would have thought, right? So I like to use it just because I love the name and it makes me happy. But, use whatever. This is just an embedded Mongo DB. I'm going to now go to my main application class. And again, oh, this is terrible. You probably can't see that from the back, can you? Let's see, font. So let's blow this up here a little bit. Let's take that up to ambiguous. Okay, so is that better? Can you see that in the back? Yes, I'm getting thumbs up. If you can't, shout, we'll fix it. So let's get started. I'm going to create my domain first, so I'm going to just create a class. We're going to call this cleverly enough coffee. With Kotlin, you can actually provide well, you don't have to have multiple constructors in most cases. You can. But unlike Java, you have a way to create one very super powerful primary constructor. And if you define that, you can define it in the header. Now, the neat thing is you don't even have to have the constructor keyword. You can just start here. So that's kind of sweet and kind of concise, right? Oh, I did kind of skip past. I do want to store these coffee objects in Mongo, so I'm going to annotate this with that document. I'm going to indicate that this is my ID field, and then I'm going to create a value, not a variable. This is literally like a Java final, right? You're going to assign it once, 0 one time. So I'm going to create an ID field. I'm going to make this a string, a Kotlin string. Now in Kotlin, when you say something's a string, it is always a string. It can never have a null value, so you know exactly what you're getting. But in this case, Mongo is going to be assigning my ID, so I need to say it's okay to be null, right? So you need to somehow indicate this is not always a string. It can be a string. So you can tell the difference by the inflection, right? This is a string. This is a string. Right? So you can tell. So this just tells you that it's questionable. Is it a string or is it not? No one knows, right? So I'm also going to assign what would be a value that if one is not provided, it will default to null, because again, I said it's nullable. And that's fine in certain limited circumstances. I'm also going to create another value, and we'll come back to this point in a moment. We'll have a name for our coffee, and this will be a string. And we'll assign a default value, which is another capability in Kotlin, which is another reason why you don't need multiple constructors in most cases, because you can provide default values, right? If I don't provide a name, I'm going to call this particular coffee, once it's created, any old Joe, right? So now, why am I defining these things? These are properties. Kotlin doesn't have member variables with getters and setters. It has properties that are by default public. You can define them to just expose the getters or just the setters, or well, both in this case, right? But that gets you quite a ways down the road. I'm also going to indicate, that this is a data class, which allows or has Kotlin provide, it takes into account that this is basically a place to store your data. It also has Kotlin provide the equals hashcode toString, the component end methods, and a copy function, right? Which gives us quite a bit of capabilities right out of the box and shortens our code dramatically. So how much easier do you think that is to maintain something like this as a domain class? Pretty simple, right? So that lets me get down to business a lot faster. I also want some operational visibility into my coffee service. So I want to track what orders are being placed for each coffee. So I'm going to create a class. We'll make this another data class, and this will be our coffee order class. This will have, let's see, a coffee ID of type string, and let's see, we'll also want a value for a timestamp, right? When ordered, because we want to be able to track when a particular coffee is ordered. If a coffee is ordered 1,000 times per minute, that's a popular coffee. We need to stock more of that and stock similar coffees, right? If a coffee is only ordered once every year, we can probably safely drop that from our catalog. This is important stuff to know. So I'm going to create my coffee order operational class, if you will. And next I'm going to create an interface. We'll call this our coffee repo. And this will extend. Notice instead of having you extend, we just have a colon, which extends a reactive CRUD repository interface defined in Spring Data. And we're going to be storing objects of type coffee with IDs of type string. And this, just defining this interface is enough for Spring Boot, its auto configuration to kick in. Because we're extending an interface defined in Spring Data, and we have a database driver on our class path. Spring Boot takes its auto config and says, well, if you have both those things, chances are you want to talk to a database. This is what some folks call magic. I don't know. It doesn't seem that magical, right? It's technology. It's not that hard, right? So we're going to define this interface, and we're going to let Spring Boot's autoconfig take that for us. Again, if you want to handwrite it, you can. Let's not. The next thing I want to do is just create a component, right? A component that will allow me to load some data. So this will be our class data loader, and I'm going to inject our repo here into our data loader. Now, I've declared this private, and this just means that I don't want to expose our coffee repo via our data loader class. There's no real reason to do that, right? Because it's available. It's a bean. It's available throughout the application. So we're just going to use that within our data loader. I'm going to create a post construct method, private fun, and I should say, Kotlin doesn't have methods. It has functions. And the keyword for functions is fun, which leads us to the expression, it's always fun in Kotlin. Good stuff. I should have warned you. I mean, the jokes don't get any better from here. So, again, unintentionally funny. Yes, exactly. I'm learning more and more why my wife says that. I don't get it. Okay, so the other thing with Kotlin is you don't have to define your function bodies like this. If you can evaluate a single expression and provide the implementation of this, just assign it, which makes it a lot cleaner as well. So I'm going to create a flux of just these coffee values. So let's quickly plug in a few different coffee values like latte, spelling is a thing, cappuccino. Is it 1P or 2? Yeah, that's right? 2. Oh, dear. Okay. See, I never get that. All right. Audience participation is key. Okay, so macchiato, right? Let's see, what else? Espresso. How could you let me forget espresso? Audience, I'm counting on you. Okay, anything else? Any others? Americano. Okay, we can do that. Americano. For those who like weak coffee. All right, I like it all. I mean, all kidding aside, I like it all. There's not a kind of coffee you can throw at me that I won't drink, except bad coffee. That's terrible. Okay, anyone else? What, Turkish coffee? Okay. Turkish coffee. Okay. Irish coffee. Oh dear, we're going there, huh? Okay. Okay, we'll just stop at Irish coffee. That's fine. But we'll come back to this. So we're going to take the flux of just these values, and then I'm going to map those. So what I'm going to do is create a new coffee. There's no new keyword. It's superfluous, right? We don't need it. We know we want to create a new coffee, and we have our named parameters. So we're going to set name equal to it. It is the default parameter for a Lambda. If you don't specify it, you can specify it if you want, but it defaults to it. It's so clean. So let's see. We need to then flat map each of our coffees. So we can do a repo.save it, right? And then we should subscribe. Because if we don't subscribe, if we just stop here like we would in the imperative world, what happens? Nothing, right? Because reactive applications are like me. Publishers are like me. They're lazy, right? You need something like a terminal operator, like in Streams. So we're going to just subscribe to that, and I'm just going to do a print line of it, and that'll tell us what's going on. Now that's not horrible. We can do a little bit better because we're going to be starting and restarting this application several times, and each time we do that, it's going to try to save the same coffees, right? So we need to do a little cleaning, a little house cleaning here. So let's do a repo.delete all. And again, in the imperative world, we'd just stop here, right? It'd delete everything, then we'd add them. But we can't be sure that the delete all operation will finish before the next one kicks off. And that gets a little awkward, right? So we need to do something. Now, we could do a block. It's a valid operator, right? But if you find your non-blocking code starts getting littered with blocks, you should probably question your life choices. Yeah, bad idea. So what I like to do is use something like a then many, which actually waits for the signal from upstream and then expects a publisher and then carries on with processing, which we just happen to have a publisher right here, a flux that we've just created, right? Flux is a publisher, and that's pretty good. But what we should do, because right now it's just printing each one out as it's saved, we'd like to verify that's truly all we have in our repository. So I'm just going to chain another then many in there and do a repo.findAll, and there we go. So let's run this and see what we have. Look at that. It actually works. Okay, good. So we're not burning down the office yet. So we have saved some coffees in our database fully reactively. We've not blocked once. So now let's go ahead and launch in because I see my time is dwindling and there's so much I want to cover. So the next thing I want to do is just build my internal interface, right? So I'm going to create a service. We'll call this coffee service. Clever, right? Service. We're going to inject our repo once again so we can use that. So what do we need to do? What kind of an internal API will we need? Well, we'll probably want to get all coffees. Coffees. And let's see, we'll just do a repo.find. Oops, I always skip that. That's just so embarrassing. Val. So repo.find all. Straight pass through, pretty simple. Another thing that we'll probably want to do API-wise is be able to get a coffee by its ID, right? So let's see, we'll pass in an ID, and we'll do a repo.find by ID, by its ID. And then finally, we'll want to be able to get that operational data, right? So we want to do a get orders for a particular coffee ID, and if we had this in production with dozens or hundreds of coffee shops around the world, we would have this probably in an in-memory data grid where we'd just say, oh, here are the current orders as they're rolling in. We don't have that because we so far have no customers. But I'm hopeful. 2019 is going to be the year. So until then, we're just going to simulate this. I'm going to do a flux.interval, and we're just going to create an interval based on a duration of once per second, right? And then I'm going to do an on back pressure drop. And as I mentioned earlier, you have the ability to tweak how you want to handle with back pressure. If you have a slow consumer that can take 10 values for every 1,000 you produce, what do you do with the other 990? Now, you can set a buffer, you can buffer a certain amount and things like this. In this case, I don't care. So it's sort of like a dashboard. You only care what's happening now. So I'm just going to drop any intervening values. It's fine, but you have that power, right? The next thing I'm going to do is map each one of those values, or each time that pulse comes in, I'm just going to create a new coffee order. I'm going to use our coffee ID that we're requesting, and then I'm just going to provide a timestamp of now, right? Instant.now. So that's pretty good. Now, what I normally like to do in these situations is show you how to build out the tests. I have a full set of repositories I'll show you the link to later. But since we're so short on time, I'm just going to do like we do all the time in production all the time. I'm just going to skip the test. Is that okay? Yeah, sure, because we never do that. Okay. I feel so embarrassed right now because actually tests are the most important part, but trust me, they're in the repo. So sure they are. They are. They really are. Okay, so let's go ahead and create our external API and let's build out from here. So I'm going to just create a REST controller and do a request mapping, and we'll start with a base URL of coffees, and this will be our class coffee controller. And let's see, we want to inject our private, come on, let's see. Private val. We're going to inject our service so we can build our external API around our internal API. Kind of makes sense. Let's create a get mapping. This will be a fun all. We'll just say all equals service dot get service dot. Oh dear, thank you very much. Yeah, just rolling forward here. Coffee service, there we go. That should work considerably better. Okay, so get all coffees. Again, straight pass through. This will be a get mapping. We're going to want to grab a particular coffee by its ID, fun by ID. Again, we're going to use a path variable for the ID equals service dot get coffee by ID. Again, pretty simple. So finally, for that operational data, we want to grab orders for a particular ID / orders, fun orders. Come on, IntelliJ, catch up with me here. So ID string, and in this case, we're going to, again, use our service.getOrders for the ID, and that's almost enough, right? But with a REST controller, typically it waits for all the values to come back before it sends them on down in a single document. We have created this flux that's just pulsing once per second, right? So this will continue until the heat death of the universe, or until we stop the application, one or the other. So we know this is going to just keep going, so we don't want it to wait our controller to wait for everything to come back before it sends it downstream. So we need to indicate it can use something else, something like a WebSocket or a server sent events. In this case, it kind of makes sense to use server sent events since we're just doing a one-way push pulse each second. So media type dot text event stream value, and then I'm just going to wrap that with an array of, and let's run this. So this should work. No tests. It's all very exciting. Hopefully it will. Oh, well, yeah, this is IntelliJ 2018.3 has this built in to where single instance only is the default. Sadly, I'm on 0.2, so we're going to just set this and then make this go again. So let's see, control, cancel. No, don't do that, Siri. Okay, so there we go. And let's test this. I like to use HTTPy. It's curl for mortals, right, for humans. So let's check our coffees. It's so pretty. And let's see, let's grab the Americano. And let's drop that in. And let's also check the orders. So we should have orders here, right? Oops. Control A. So let's stream those. And that just works so nicely. Isn't that pretty? So it all works. Now, what I normally do at this point is fix it. Right? We can break it, we can rebuild it, we can do a functional routing. Again, we don't really have time to do that and still hit our time mark. So what I'll do is point you to the repo for that, but let's build a client. Let's do a Java client just for giggles, right? So I'm going to go back and switch this. Why not? Let's do Maven and Java, and I'm going to change this to a coffee client. And I'm going to remove Mongo. Don't need Mongo for our client here. And I'm going to add Lombok again because I'm a lazy developer. Lazy good, not lazy bad, in case anyone's wondering. My boss may watch this. So let's see. So let's go open this, and we'll open this once again. Okay. So I'm going to do a couple things. I'm going to go to my application.properties, and I'm going to make sure we don't have any port conflicts. Port conflicts are bad. And then I'm going to go to my main application class. And then I'm going to define the same domain here using Java. So it's a bit more verbose, but with Lombok, it cuts it down quite nicely. I'm going to create a data class in Lombok, no args constructor, all args constructor. Come on, Lombok, help me out here. And then let's see, we'll create this class coffee. And we want a private string ID and name, and that's good enough. And then we have our coffee orders. So class coffee order, private string coffee ID, private instant when ordered, right? Oh yeah. And once again, we're going to make this data at no args constructor, at all args constructor. And then let's just get started here. Let's do a bean here to use a reactive web client. Now this is really cool because in Project Reactor and Spring Web Flux, web client is actually kind of the REST template replacement, but it has more blades than the Swiss Army knife. Right? It can hit blocking endpoints. It can hit reactive endpoints. It does it all. So it's kind of the way going forward. It's pretty sweet. So we're going to client, if I can type, return web client.create. And I'm going to just point this at a base URL of localhost 8080/coffees because that's where we know we're going to start from. I'm also going to create a command line runner bean, which will execute each time our app starts. We're going to inject our web client here, and I'm going to provide the Lambda, the implementation for our single abstract method in our command line runner functional interface. So return args client.get, and we're going to retrieve the value for that. We're going to convert that body to a flux using coffee.class as our flux coffees, if you will. I'm going to filter that. So we're going to filter that down to coffee.getName equals ignore case. Let's go latte, shall we? And then I'm going to flat map the coffee coming out of that and do another client get, right? Because why not? And I'm going to add to the URI. I'm going to point to ID orders so we can grab the orders for that. Orders. And let's see, coffee.getID. And let's do a retrieve and body to flux that. We're going to be retrieving coffee orders, and let's subscribe. So once again, we can kind of see what's happening. Boom. Much nicer. OK, so let's run that. And assuming that works, we have 2 whole minutes left. I can go back and wrap it up, and we're good. If not, we'll debug it, right? OK, so look. First try, even. What do you know? OK, so very quickly, that's not too shabby, right? So we covered Kotlin. We covered Java. It's all very similar. The Kotlin is just a little bit less verbose, which is kind of nice. And it gives you quite a few capabilities just baked into the language, which is also pretty sweet. So let's go back here, and let's wrap this up. Back to our friend Maurice. So, some helpful resources. If you want to know more about the Reactive Streams initiative, the history, the context, all the API docs, the textual spec, it's all there, reactivestreams.org. If you want to know more about Project Reactor, we actually have some really good documentation, which is awesome. If you want to know how to debug, if you want to know how to trace, if you want to get into the internals, it's in there. It's very nice, nicely written up. So projectreactor.io is kind of the place to go, the reference site. And then finally, the GitHub repo for FSR, the full stack reactive. I have both client and service written in Java, both client and service written in Kotlin with tests. And also an R2DBC project that I did with a link to a 17-minute video on how to do reactive relational database access, using Postgres in that case. But please do check it out. It's early days for that, and if you want to get involved, please do. And with that, hey, thanks for coming. Oh, please do rate the talk. 5 stars is enough. You don't have to do 6. It's OK. Thank you very much. I really appreciate it.